guys, today we're going to do 4-3 part 1. We're going to have a little introduction into the unit circle, and we are going to see special right triangles in our unit circle. So this is going to be part 1 of 4. First, we have our coordinate plane broken up into quadrants 1, 2, 3, and 4. We know that we start 0 here. We go up to 90, 180, 270, and then 360. Or in radians, we would be 0, pi over 2, pi, 3 pi over 2, and 2 pi. Then if we have a negative angle, we still start 0 here, but now negative 90 is at the bottom, negative 180, negative 270, negative 360. And just like the degrees would be the radians, so negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. Now, we were very familiar with graphing all angles on a coordinate plane, but now we have something called the unit circle. And if we know something about a circle, we know that we have a radius. And the radius of our unit circle is going to be equal to 1. And the center of our circle is going to be at the origin. So I'm going to use my water bottle, sorry. We're going to pretend that that circle centered on our coordinate plane. And if we say that our radius is 1, that means our distance from the center to any point around the circle would be 1. So since I'm on the coordinate plane, I know that I can make this coordinate to be 1, 0. And then if I just went up 1, this would still be a radius of 0, 1. Negative 1, 0. And down here would be 0, negative 1. And we are going to graph in our circle. So say I graphed an angle over here. And we can say that this angle is 135 degrees. This point here hits my circle, which means the distance from the circle to my center would be 1. And I can make a triangle with my x-axis. So if I use my x-axis, the straight line down from my angle to my x-axis, and my terminal arm, I now have a triangle. This triangle is where we use to find our reference angle, theta. So I'm going to put a theta on the inside there. And now this theta, which would be 180 degrees minus 135, which is 45 degrees. This 45 degree angle is going to help us find the sine, cosine, tangent, cosecant, secant, and cotangent of 45 degrees, which is then going to be related to the 135 degrees. So we need to bring back these 45, 45, 90 triangle and 30, 60, 90 triangles. First, 45, 45, 90 is the same as pi over 4, pi over 4, and pi over 2. So this is a conversion that we need to be very comfortable with. Pi over 4 is the same thing as 45 degrees. And our legs were x and x, but our hypotenuse was x root 2. And our angles are 45, or pi over 4, and a right angle, which is pi over 2. So now if I took this and related it back to here, where I have a 45, 45, 90 triangle, but my hypotenuse is 1, I want to know what my legs of my triangle would be. So we only have to do this one time, and then we can just keep using this, the work that we've already done. So I know x root 2 is equal to 1, because that's my radius in my unit circle. So x root 2 equals 1. I solve for x by dividing by root 2. X is equal to 1 over root 2. Rationalize. And x is equal to root 2 over 2. Which means the triangle that we want to remember and put into our unit circle will be root 2 over 2, root 2 over 2, and 1. So, across from 45 degrees, or pi over 4, is side length root 2 over 2. Now we need to do the same thing for 30, 60, 90. 30 degrees is pi over 6. 60 degrees is pi over 3. 90 degrees is pi over 2. I'm going to label my angles and then my sides accordingly. So across from 60 was x root 3. Across from 30 was x, and my hypotenuse was 2x. But I want my hypotenuse to be equal to 1 so that it fits into my unit circle. Therefore, 2x equals 1, so x is equal to 1/2. X is equal to 1/2. That means 1/2 root 3 is going to be root 3 over 2. So the 30, 60, 90 that we need to remember will be across from 30 is 1/2, across from 60 is root 3 over 2, and our hypotenuse is 1. So across from 60 degrees, or pi over 3, is root 3 over 2. And across from 30 degrees, or pi over 6, is a side length of 1/2. So in order to evaluate trig ratios for any angle, we're going to first draw our angle on the coordinate plane. Then we're going to make a triangle with our x-axis. If we need to find our reference angle, then we find our reference angle. We always label that angle theta. We need to find our reference angle if our angle is greater than 90 degrees or if it's negative. So if it's not an acute angle, we need to find our reference angle and label it theta. We label our triangle's sides. And then we find our trig values based on theta. So let's try and find the 6 trig functions of 45 degrees. I'm going to draw 45 degrees. I then need to make a triangle with my x-axis. So I go straight down, and then my x-axis is the third side of my triangle. I label the angle theta. So this 45-degree angle is theta. Across from 45 in my triangle is root 2 over 2, root 2 over 2, since this side is 45 as well. And my hypotenuse is 1. I then need to find the sine of 45 degrees. The sine is opposite, which is root 2 over 2, over 1. Root 2 over 2 over 1 is root 2 over 2. The cosine of 45 degrees from theta, the adjacent side is root 2 over 2. The hypotenuse is 1. Therefore, our answer is root 2 over 2. The tangent of 45 degrees is opposite over adjacent, which is root 2 over 2 over root 2 over 2. Anything divided by itself is 1. The cotangent of 45 degrees is equal to the reciprocal, which is 1. The secant of 45 degrees is the reciprocal, which would be 2 over root 2. I need to rationalize by multiplying by root 2 over root 2. I get 2 root 2 over 2. The 2's reduced to 1, and I'm left with root 2. And I don't need to do all of this math again because I know that the cosecant of 45 degrees is going to be the reciprocal of sine, which is 2 over root 2, which is equal to root 2. You guys try to find the 6 trig functions of negative 120 degrees.